Classification of colloids. See, classification of colloids is mainly done on three different criteria. The first is on the basis of their state. Their state means the state of the dispersion phase and dispersion medium particles. See, so if, let us see here, this is for the dispersion phase, this is for dispersion medium, what name we give to that particular type of colloid, and what all the examples we can have. So if the dispersion phase is solid and the medium is also solid, so we call it solid in a solid. It's called solid sol. And remember, gemstones, some colored glasses are the best examples of this. So when we have a solid in a solid, it's called solid sol. Gemstones like ruby, sapphire, etc. are the best examples of this, or the colored glasses, because glass becomes colored when we add certain metals to this. So metals are solids in another solid. It's an example of a solid sol. When we have the second type, a solid in a liquid, we call it simply a sol. So a solid in a liquid is called sol. We have number of examples of these sols, like we have silver sol, gold sol, ferric hydroxide sol, starch sol, etc. Gum, gelatin, all these are the examples of the solid in a liquid. Then the third type is of a solid in a gaseous medium. So dispersion phase is solid, dispersion medium is gas. It's called aerosol. Aerosol. And the examples are smoke, dust, etc. are the best examples of a solid in a gas, which we can see that they always remains dispersed, the smoke and the dust. Now the fourth type of the colloid we can have is in which we have a liquid in a solid. So when the dispersion phase is liquid in a solid dispersion medium, it's called, remember, gel. So our hair creams, our toothpastes, all are the jellies, the jam, jellies. All are the examples of this. Then we can have a liquid in a liquid. When we have a liquid in a liquid, it's called emulsion. Emulsion is the type of colloid in which we have both dispersion phase and the dispersion medium in the liquid state. So a liquid in a liquid is called emulsion. Example, milk, cod liver oils, all are the examples of your moisturizers or your cold creams are the examples of emulsions. Then let us see the next one. Next category of colloid, sixth category, can be of liquids in a gaseous medium. So when the dispersion phase is a liquid, medium is a gas, we call it aerosol. Yes, it's again is aerosol, but the examples here are your fog, mist, example of the aerosols. So when we have a liquid in a gas, it's called aerosol, fog, mist are the examples of this. Seventh category, we can have a gaseous dispersion phase in a solid medium. Now it's called again solid sol, and the best examples are pumice stone. The pumice stone is the best example of this one when you have a gas and a solid. Similarly, the eighth category of the colloid we can have is in which we have a gas in a liquid. So when the dispersion phase is gaseous, medium is liquid, it's called foam. So the soaps, lather or the froth which we get are the best examples of a gas in a liquid. So these are the basic 8 types of colloids we have on the basis of their state, in which we normally have in our syllabus the simple sols, and the other examples we have are of the emulsions, which we'll be doing in detail later on. Classification. The second classification of the colloids is, this is second classification on the basis of interaction between dispersion phase and dispersion medium. How these two phases of the colloids have, what kind of an interaction they have. Now on this basis, colloids are of 2 types. One are called lyophilic colloids, and the second category is of lyophobic colloids. Let us take these one by one. Now, lyophilic colloids as the name suggests, lyo means solvent and philic means affinity. It means these are those colloids with affinity for dispersion medium are called lyophilic colloids. These are the colloids which develop interactions or affinity with dispersion medium. Those type of colloids are called lyophilic colloids. Now, since they develop affinity with the medium very easily, you need to remember that they are prepared easily just by mixing dispersion phase with dispersion medium. We don't have to do something extra to prepare them. The moment you mix them in the suitable medium, they are directly formed. So they are prepared easily, directly, just by mixing the dispersion phase, dispersion medium. Another important thing, since the interactions are there, these interactions can easily be broken down also. So their preparation is they are reversible. You can separate the dispersion phase and the dispersion medium. So the preparation is easy and this separation is also easy. Then the next certain important points regarding these. They are very stable. They doesn't coagulate or precipitate out easily. You will learn more about this thing later on when you will realize the word, the meaning of the word coagulate means how it's not happening like we put the dispersion medium and the dispersion phase in the suitable medium, and after some time you find that the dispersion phase gets separated or precipitated out. It's not like this. They can be kept for a very long time as they are very stable in their nature. So that's the most important factor we have. So they are reversible, they can be easily prepared, they are very stable, and the best examples of these kind of colloidals we have are your starch sol, your gum, gelatin, etc. All these are the examples of your lyophilic sols or lyophilic colloidals. Now let us take the second. The second category of colloidals on the basis of their interactions are lyophobic colloids. Now, as the name suggests, lyo means solvent and phobic word means hating. So these are the colloids which doesn't develop affinity with dispersion medium. They doesn't have good interaction with the dispersion medium. So colloids with poor interaction with dispersion medium are called lyophobic colloids. So since they doesn't have the affinity or they have a poor affinity, you just can't prepare them just by mixing the dispersion phase in the suitable dispersion medium. You need to do certain very specific different processes in order to prepare them. That is why what we say is they are prepared with difficulty. They cannot be prepared easily. They are prepared with difficulty. And once they are prepared by certain very specific and special property processes, you cannot separate them out. So they are irreversible. You cannot then separate the dispersion and medium from each other. Then the most important property which we find in this is that they are not very stable. They are not very stable. They easily coagulate or separate out. The dispersion medium cannot be kept in the dispersion phase cannot be kept in the medium for a longer time. It easily gets separated out in the form of the precipitates. So they are not very stable. You cannot keep them for a longer time. So these are the basic properties of the lyophobic colloids. The example are your gold sol, silver sol, ferric hydroxide sol, etc. All these are the examples of lyophobic colloids. Third classification of colloids is on the basis of the particle size. So I am discussing third classification. It's on the basis of particle size of dispersion phase. Now on the basis of particle size of dispersion phase, remember we have three types of colloids. The first category is of multi-molecular colloids. Multi-molecular colloids, as the name suggests, these are the colloids whose particles are of normal true solution range, or of a very normal true solution range, but when added to the suitable medium, they aggregate together to form large size particles whose sizes are lying in the colloidal range, and this is how on aggregation they form the particles of a colloidal size. That is why they are called multi-molecular colloids. I am repeating, the particle size is of true solution, but they aggregates to form colloidal range particles which are of the size bigger than 10 to the power minus 9 meters. So that is why what we find is we can show it like this, that all these smaller particles, they aggregate to form a very large big size particle whose range is lying above 10 to the power minus 9 meters. So that's the most important thing. That is why we call them multi-molecular, that they are made up of many molecules, which are actually, each one of these are of the true solution range, but they aggregate to form large particles. Example of these are your gold sol, silver sol, etc. Remember, these usually are of lyophobic category, but they have aggregated to form such kind of a colloidal range particles. So this type of colloids are called multi-molecular. The second type of colloidals on the basis of the size of the particles of the dispersion phase are macromolecular colloids. See, as the name suggests, macromolecular. These are the colloids whose particles are already of very large size, So the moment you put them in a suitable medium, they directly form the colloidals. They directly form colloidal system. The reason is their particles, individual particles, are already as large enough and they are of the range of a colloidal size. That is why the moment you put them in medium, they directly form the colloids. And the best example of these are your polymers, mainly the starch, gum, gelatin, proteins, enzymes, we can have like polythene, polypropylene, all these. See, the molecules already are very large. So the particles are already of the colloidal range. So they directly forms the colloid, and that is why they are called macromolecule, because they are already of a very large size. They usually are lyophilic in nature, because that is why they directly form the colloids, and the best examples are all these salts or colloids. So remember, these are basically lyophilic. The third category under the same heading is of associated colloidals. Associated colloidals, as the name suggests, the particles are of true solution range, but they aggregates to form colloidal range particles only above a certain minimum concentration and temperature. Remember, these are the colloids whose particles actually are of true solution range, but when added to suitable medium, they aggregate to form a colloidal range particle. But then why we are not calling them multimolecular? There is a reason. Because they associate only above certain minimum concentration and temperature. And you need to understand that certain minimum concentration is called CMC, critical micelle concentration, because on aggregation, whatever the colloidal range particles they formed are called micelles. So that's why it's called CMC, critical micelle concentration. The minimum concentration required by the particles to aggregate to form a colloidal range particle is called micelle, or the minimum concentration required for the micelle formation is called critical micelle concentration. And we have a temperature which is called TK. It's called Kraft temperature. It is the minimum temperature above which the aggregation of the colloidal particles takes place to form a colloidal range particle. So it is the minimum temperature above which the micelle formation takes place is called Kraft temperature. So these are the two essential conditions. Now remember, which type of colloids are associated colloids? All surface active agents like soaps, detergents, synthetic detergents, whatever we have, all of their molecules which are surface active agents are the examples of associated colloids. You might have done in your junior classes about the soap molecules, like if we talk about C17H35COO minus Na. This is sodium stearate. Now in this we know that this is your fatty acid. Long chain fatty acid is having a carbon chain of 17 carbons, and its head is having this carboxylate group. Now this part is a lyophilic part. This whole carbon chain part is your lyophobic part. So remember, these associated colloids has both lyophilic as well as lyophobic parts. Now they all aggregate above CMC and Kraft temperature to form what? To form large size particles which are almost are like this. You must have done in your junior classes. Now this is the head part which is negatively charged, and all their lyophobic parts are actually are turned towards inside, and they are all lyophobic, sorry, are turned inside, lyophilic are towards outside. So they forms a spherical ball like structure. Hundreds and hundreds of these molecules combines together, these ions, and now this aggregated part is called your micelle. Now it is very stable now, the reason being it's having a negative charge on its surface, so it gets easily hydrated, whereas all the lyophobic parts are towards inside, which again gets balanced with each other. So this is how the micelle formation takes place. So all surface active agents like soaps, detergents, they shows this kind of a behavior. And you must have seen, like in the winters we cannot wash the clothes in the cold water. That is reason because below a certain temperature the micelle formation doesn't take place, and the clothes are always only washed when we have a micelle formation in the solution. So that is how they work.